Hello my dear students, welcome to IMS Gate Academy. I hope all of you are attending our previous 4 sessions of communication system subject which we have discussed. In the last 4 sessions we have discussed the recent gate questions. We have discussed good number of gate questions which are asked in the recent 4 years, that is 2023, then 2022, 2021 and then 2020, right? So all of you kindly share your experience in the chat, and whoever attending this video link later, right? So after watching each and every lecture, whatever you have learned something new in the previous lectures and whatever you have liked the most in that lecture, you can comment in the comment section, right? So I hope in the last 4 sessions, I hope all of you got the good confidence in the communication system subject, right? So in this particular session will increase further confidence regarding communication system subject. Okay, so all of you will get the confidence level further higher, right? So in this particular session we are going to discuss good number of questions which are asked in the year 2019. Okay, so in this particular session, whatever the questions I am going to discuss, those are very much interesting questions and which are very much helpful for your coming GATE exam as well, right? So I hope all of you are eagerly waiting for the session. So let us start. So this is the question asked in GATE EC in the year 2019 for 1 mark, and this question is of NIT type. So answer will be a number. So all of you read the question carefully and try to solve this question, and after solving whatever the answer you are getting, you can mention in the chart, right? All of you give a try. Yeah, time up. So whatever the answer you got, you can mention in the chart. This is the NIT question, so there won't be any negative marking in the exam. So during our classes, in the live classes, there is no negative marking for any question, right? So whatever, after solving any question, whatever the answer you are getting, you can mention in the chart. Okay, right. So in this particular question, if you observe, they have given the PM signal, that is nothing but phase modulated signal. So regarding the phase modulated signal, they have given the expression like this: cos 2 pi f ct plus k into m of t. In general, you are familiar, I hope, regarding the standard signal of phase modulated waveform. That is nothing but AC into cos 2 pi f ct plus kp into m of t. In this question, AC is nothing but 1, that is a peak amplitude, because here you don't have any value. So that means this overall term is getting multiplied by 1. So that is nothing but peak amplitude of that particular signal. So AC equal to 1. Here you are having cos 2 pi f ct plus kp into m of t, but in this question they have considered simply k. That is nothing but phase constant. So in this question, regarding the phase constant, the k value they have given 10 pi. And regarding the carrier frequency fc, they have mentioned 50 kilohertz, 50 kilohertz, right? And in this question, regarding the m of t signal, regarding the m of t, they have given the waveform like this. So all of you please respond, what is this particular waveform? When you have observed this particular waveform, so what is your observation point? So here you are having the waveform in this particular fashion. It is in the triangular form, yes or no? It is in the triangular form, right? Okay, and it is a periodic waveform. It is a periodic waveform. Okay, so regarding m of t, they have given the waveform like this, and in this question they are asking that the ratio of minimum instantaneous frequency in kilohertz to maximum instantaneous frequency in kilohertz. So that means they are asking the ratio of two numbers. In both the numbers you are having with respect to instantaneous frequency only. In the numerator you have to consider minimum value, whereas in the denominator you have to consider maximum, right? So like we have solved similar type of question in the last class, right? So there we have considered one signal like increasing, linearly increasing, and then constant, after that linearly decreasing. Like that waveform we have considered. So in the last class we have discussed one question. In that particular question they have mentioned regarding the phase modulated signal and frequency modulated signal, they have considered the same message signal, right? So they have mentioned that in both the cases the respective constants are same. So after that they are asking, okay, they are asking the relation between kp and kf by considering the instantaneous frequency is same in both the cases. Okay, that question we solved in the last class. So here in this particular question they are focusing only with respect to PM signal, right? I hope all of you know the formula regarding the instantaneous frequency. Can you recall? Can you recall the formula for instantaneous frequency? So all of you please mention the chart quickly. When you are having either cos signal or sine signal like this, okay, whatever the term here you are having, entire term you can consider like theta of t, okay. So from there we can write instantaneous frequency Fi equal to 1 by 2 pi into d theta of t by dt. 1 by 2 pi into d theta of t by dt. So here you can keep 1 by 2 pi as it is. 1 by 2 pi as it is. Here we have to perform differentiation with respect to time, and here we have to consider theta, where theta is nothing but here whatever you are having cos of entire term we can consider theta, where theta is nothing but 2 pi f ct plus k into m of t. Theta is nothing but 2 pi f ct plus k into m of t. K into m of t, right? I hope all of you know the differentiation how to perform. It is a very simple differentiation. I hope all of you get easily. Here 1 by 2 pi I am keeping as it is. Here in this particular term 2 pi f c is the constant. 2 pi f c is the constant. So we can keep that constant as it is. Now all of you please respond. Differentiation of t with respect to t. What you will get? Differentiation of t with respect to t. You will get 1. Plus here k is the constant. K is the constant. Right. Then differentiation of m of t with respect to t. dm of t divided by dt, right? So whatever the values they have given, let us substitute. So before that, let us multiply 1 by 2 pi with the both the terms. Okay. So in that case, 2 pi will get cancelled. You are going to get fc, that is a carrier frequency, and then here you will get k by 2 pi into dm of t by dt. I hope it is clear for everyone up to this step, right? So now, according to the given question, the carrier frequency they have mentioned 50 kilohertz, and the constant value, phase constant, they have mentioned 10 pi. You can substitute these two values here. 50 kilohertz, fc is 50 kilohertz. So for the timing, I am writing 50,000 hertz. Okay, and then k value they have mentioned 10 pi. K value they have mentioned 10 pi divided by 2 pi into this term as it is, dm of t by dt. So here 2 pi how many times? 5 times. 2 pi into 5 is nothing but 10 pi. So from here you are going to get one equation like this: 50,000 plus 5 into dm of t by dt. 5 into dm of t by dt, right? So this is the instantaneous frequency you got. Instantaneous frequency you got 50,000 plus 5 into dm of t by dt. Now just observe this particular equation and tell me in which case you are going to get instantaneous frequency maximum, in which case you are going to get instantaneous frequency minimum. With respect to what parameter in this entire equation, with respect to which quantity or parameter, we can say that whether instantaneous frequency is maximum or it is minimum. Any guess? We have already covered this model in the last class. See, it is very simple. Here 50,000 is what? Constant, right? Here 5 is also constant. Only variable term is what? dm of t by dt. Because here regarding m of t, they have given the waveform like this. With respect to time, it is varying, right? With respect to time, it is varying. So that means based on this dm of t by dt, here we can decide whether the instantaneous frequency, whether you are going to get maximum or minimum, right? So now with that understanding, you can easily tell that when dm of t by dt is maximum, because here we are adding these two terms, right? So if this dm of t by dt is the maximum, in that case, the instantaneous frequency obviously you will get maximum, right? Similarly, when you are considering this value is the minimum, obviously the overall value you will get less when compared to the earlier case. So with respect to that, you can say that you are going to get the instantaneous frequency minimum, right? So now in order to find the maximum instantaneous frequency or minimum instantaneous frequency, so for that, first of all, we have to calculate dm of t by dt. Okay. So for the timing, I have considered whatever the message signal waveform they have given. So I have considered once again as it is here, right? Now if you observe carefully here, if you observe this waveform carefully, so it is a periodic waveform. Whatever the waveform here you're having, like from 0 to 3, within this duration, here you're having time in the order of milliseconds. In this question, this is the most interesting thing and important thing. In general, you'll be having time in the order of seconds. Okay, sometimes they will represent in the order of millisecond or microsecond, etc. So whatever the units they have mentioned, exactly we have to consider like that. But sometimes students will do silly mistake here. Here they have given actually millisecond, but by mistakenly if you are considering simply like seconds, so because of that you may get wrong answer, right? So you have to take care about the units, and the order of the units also very important, right? So here from 0 to 3 millisecond, whatever the waveform here you're having, the same waveform it is repeating, so that means it is a periodic waveform. Now within 0 to 3 millisecond, if you observe the given waveform, we can make into two intervals. Say for example 0 to 1 millisecond, and then 1 millisecond to 3 millisecond. 1 millisecond to 3 millisecond. You can closely observe this waveform, how I have made into two intervals. I haven't made exactly like equal intervals. No. Here if you observe from 0 millisecond to 1 millisecond, the waveform is linearly increasing function with respect to time. Whereas from 1 millisecond to 3 millisecond, it is linearly decreasing, right? It is a decreasing function. Like that, the pattern is repeating. Now our motto is what? We have to calculate differentiation of m of t with respect to t. For that, we have to get the maximum value. For that, we have to get the minimum value, right? So in this particular waveform, just by observing this particular pattern, we have made into two intervals. In one particular interval, it is increasing function of time, whereas in another interval, it is decreasing function of time. So that means for the given waveform, just by observing the waveform like this, you can able to guess that you are going to get two possible values regarding dm of t by dt, right? So for the time being, I am considering the interval like 0 to 1 millisecond. For 0 less than or equal to t less than or equal to 1 millisecond. Okay, so in this particular interval, here regarding this particular straight line, you are having one point here. This point value is what? This point value is with respect to x-axis. Here you are having time, so that means it is 0 millisecond. And the corresponding y point, you are having minus 1 volt. Here m of t units are volts. Okay. So that means this point is nothing but with respect to x-axis 0 millisecond, right? And here with respect to y-axis, you are getting minus 1 volt. Similarly, this particular point coordinates here with respect to time axis, you are having 1 millisecond. The corresponding voltage value, you are having 1 volt. So whenever for any particular straight line, if you know any 2 points on the straight line, you can easily calculate the slope. Okay, so slope is nothing but slope of the line is nothing but y2 minus y1 divided by x2 minus y1. In general, if I am considering like this y-axis, this x-axis, in that case, the slope of the line is nothing but y2 minus y1 divided by x2 minus x1. So slope of the line is nothing but differentiation of the signal with respect to time. So that means here you are going to get dm of t by dt. So in this particular case, y2 is 1 volt minus y1 is minus 1 divided by x2 is 1 millisecond minus x1 is 0 millisecond. Right? So 1 plus 1 is 2 divided by 1 minus 0 is 1. Milli is nothing but 10 power minus 3. Here you are going to get units. Numerator you are having volts, denominator you are having seconds, so that means volt per second, right? So this denominator term 10 power minus 3, when you bring to the numerator, it will become 10 power 3. So from there you can write this value as 2k volt per second. So if you want to write normal way, you can write in the place of k, you can write 1000. That means 2000 volt per second you are going to get, right? So when you have observed within the interval 0 to 1, it is linearly increasing function of time. So for that, the slope you got 2000 volt per second, or in short you can mention 2k volt per second, right? Now with this understanding, all of you give a try in the other interval, that means from 1 to 3 millisecond. During that interval, what is the slope you are going to get? All of you quickly mention in the chart. All of you try to mention what is the answer you are getting. You can mention in the chart. Don't hesitate. Okay. So here, just like within the interval 0 to 1 millisecond, I have considered the 2 points on the straight line. Similarly, in this particular interval, let us consider the 2 points on this particular straight line. Here, 1 to 3 millisecond, you are having the straight line like this. So that means in this case, this is your x1, y1. This is your x1, y1. So whatever earlier ending point you are having, for this line, ending point is nothing but for this line starting point. So this coordinates, okay. This one will be your x1, y1. So that means 1 millisecond, comma 1 volt. I hope all of you are getting, right? For this particular line, this is the x2, y2. Here, with respect to time axis, you are having 3 millisecond. You are having 3 millisecond. And with respect to y-axis, you are having minus 1 volt, minus 1 volt. So at 1 millisecond, you are having 1 volt, whereas at 3 millisecond, you are having minus 1 volt. So once again, you know 2 points, you can calculate the slope. So dm of t by dt, which is nothing but y2 minus y1. So minus 1 divided by 3 millisecond minus 1 millisecond. 3 millisecond minus 1 millisecond, right? So here minus 1, that is nothing but minus 2. Divided by 3 minus 1 is nothing but 2 millisecond. So here 2 will get cancelled. Milli you can write as 10 power minus 3. When you are bringing to the numerator, it will become kilo. So directly I am writing here, you are going to get minus 1k volt per second. Minus 1000 volt per second. Minus 1k volt per second or minus 1000 volt per second, right? So here in this particular waveform for the given message signal, in one particular interval it is linearly increasing, whereas in another particular interval it is linearly decreasing. So obviously in whichever interval it is linearly increasing, obviously during that interval you are going to get the slope as maximum, obviously, right? Even after solving also you can easily observe these two values. From here also you can easily tell, right? So here you are getting 2000, it is a positive value, whereas here you are getting minus 1000, that means it is a negative value. So whenever you are having positive and negative values, obviously positive value will be maximum and negative value will be minimum. Okay, right. So just by observing the waveform only, you can tell in which particular interval you are going to get maximum slope, in which particular interval you are going to get minimum slope, right? So I hope all of you got the clarity how to calculate the slope or how to find out the dm of t by dt for the given waveform. Okay, so this one is your maximum. Whatever you got here, this is your maximum value. dm of t by dt max. dm of t by dt max. Whereas this value is your dm of t by dt minimum. Okay, right. Now you got the maximum value and minimum value for differentiation of m of t with respect to t. Now you can use this particular equation. Okay, when you are substituting maximum, you are going to get maximum instantaneous frequency. When you are substituting minimum, you will get minimum instantaneous frequency, right? So in this particular question, they are asking the ratio of what? Minimum instantaneous frequency to the maximum instantaneous frequency. Okay. Ratio of minimum instantaneous frequency to the maximum instantaneous frequency. So whatever the equation here you are having, I am considering same equation. 50,000 plus 50,000 plus 5 into dm of t by dt. 5 into dm of t by dt. Whereas here we want minimum. So that means here I am considering dm of t by dt minimum. Okay. Similarly here 50,000 you can copy as this plus 5 times also you can copy as this. In this case we want max instantaneous frequency. So that means dm of t by dt max we are considering. dm of t by dt max. I hope it is clear up to this step. here you're having generalized equation like 50,000 plus 5 into dm of t by dt. So with respect to case, we are considering accordingly the dm of t by dt, whether maximum or minimum. So here we got, regarding the minimum value, we got minus 1000, we got minus 1000. So here 50,000 plus 5 into, here we got minus 1000, minus 1000 divided by 50,000, you can copy as it is. Now what is the maximum value for dm of t by dt? Maximum value we got 2000, 2000, 2000. So here 50,000 is there. In short, I am representing now 50k, 50k. Why I haven't written earlier only k? The reason is very simple. For this question only, I haven't represented earlier. Instead of writing 50,000, I could have written 50k. For this question, why I haven't written? It is very simple, because in this question, regarding the phase constant, they have mentioned simply k. That is the reason. Okay, in general, we used to represent kp, right? So if they have given kp, then I could have represented 50k directly here. But here, in this question, regarding k value, they have mentioned 10 pi, right? So just to avoid confusion, I have mentioned exactly in the normal value, right? But now, just to do the simplification easily, I am representing what are the numbers here you're having in the order of kilo. I am writing. Okay, so 50k, after that minus 5k, divided by, here also same 50k plus 5 into 2, that is 10. 10k you are getting. So 50 minus 5, that is 45k, divided by 50 plus 10, that is 60k. So here kilo will get cancelled. 15 3s are 45, 15 4s are 60. So 3 by 4, I hope all of you can answer. It is a very simple question. What is the value? 3 by 4. 3 by 4 is nothing but 0.75. 3 by 4 is nothing but 0.75. So in this question, they are asking the ratio of minimum and maximum instantaneous frequency. So for this question, 0.75 is the correct answer, right? I hope it is clear for everyone. So now let us move on to the next question. So all of you give it a try. This is a simple question, but if you know the logic, you can easily attempt this question without using pen and paper. That much simple question this is. All of you give it a try. This is a question based on Hamming code concept, but here one logical operation you have to perform. I have given the hint. With the help of one logical operation, you will get the answer. All of you give it a try. Yeah, time up. See, since this question is MCQ, so you're having options right in front of you. So whatever the answer you are feeling correct, you can mention in the chart. There is no issue at all, right? Here there is no negative marking. Okay. So if you have solved and after solving whatever the answer you are getting, you can mention, or otherwise even since you're having choices, at least you can give a try. At least you can give a try. Which option you are feeling that it is correct? Because I have mentioned in this particular question, there is a logic. With the help of one logic, you might have studied various logic operations in your digital circuit subject, right? So you can recall the logic operations. You could have done some guess at least. Okay, no problem at all. Whoever watching this particular lecture later, so whatever the answer you are feeling for this particular question, you can mention in the comment section, right? Before watching the explanation part. So in this particular question, they have given a linear Hamming code. In this question, they have mentioned the Hamming code is a linear code. It is a linear code. Okay, is used to map 4-bit messages to 7-bit code words. So with the help of Hamming code, when you're having 4 bits, that time we will use 3 parity bits by using one relation. So total number of bits in the resultant code word, you are going to get 7 bit. The moment if you are changing the bit pattern in the message, so accordingly you will get corresponding parity bits and accordingly you will get the corresponding code word like that. Say for example, when you are having 4 bits, how many combinations of zeros and ones you will get? Yes, obviously 2 power 4, that is nothing but 16, right? So for every combination of message input, accordingly you will be having corresponding parity code and together you are going to get the corresponding code word. Okay, so in this particular question they have mentioned that the encoder mapping is linear. Encoder mapping is linear. So that means whatever the 7-bit code word here you are getting, that is the linear code. That is the key point in this particular question. Right. So regarding the 4-bit message code, they have considered, they have given 2 cases, examples they have given. When they have considered the message bit like this, 0001, that time the resultant code word they have given like this, 4 zeros, 111. Okay. And another case they have given, when they have considered the message bits like this, 0011, the resultant code word, they have mapped this message code to the resultant code word like this. Now the question is, when you are having the message this one, this is mapped to which code word? That is the question. Okay. So for solving this question, you can easily solve this question once if you know the basic definition regarding the linear code. Then only you can easily solve. Otherwise, you cannot solve. Okay. If you are doing some trial and error, what kind of logic is present here, if you want to apply your coding and decoding here, you can never solve this question unless otherwise you know the definition of the linear code. It is very simple. Just like forget about this code word in reality. Okay, whenever you're having the straight line, just like in the previous question also we have mentioned, you're having the waveform. So in this particular interval, it is linearly increasing, whereas in this particular interval, it is linearly decreasing, right? So consider linearly increasing case, right? So whenever you're having the straight line, if it is passing through origin, you will be having like y equal to mx, right? The straight line equation. Whenever it is not passing through origin, that time you will be having y equal to mx plus c. So in both the equations, if you observe, there is a relation between output and input. That is nothing but linear, right? So in the similar way, okay. So if you are considering like y equal to mx plus c, if you are increasing c value, obviously the resultant y value also going to increase. Yes or no? Just like here, whatever the equation here you got, you can just correlate this equation like one straight line only, right? See, here we might be studying the concepts of communication system subject, but if you are good at mathematics, then you can correlate whatever the equations here we are getting, you can correlate our analogy point of view. Whatever the equations here you are getting, you can map to your straight lines or geometric concept or trigonometry, etc., whatever possible, right? So here if you observe, you are having dm of t by dt, okay? So that entire thing is nothing but slope, okay? So here you are getting like y equal to mx plus c format, okay? So if you are considering this dm of t by dt is something like another one, another x-axis like that. Okay, so in that way also you can correlate. So here in this case, if m of dm of t by dt, if it is increasing, according the overall value increasing like that. Like that, in suppose you are having here total 3 quantities are there. Okay, if all the 3 quantities are varying, then accordingly, say for example, if you are considering all the 3 quantities are increasing, then obviously the overall value also will increase like that. Okay, so whenever you are having y equal to mx or y equal to mx plus c, so if you are adding with something, obviously because of that change in input, obviously the corresponding change you are going to get at the output, right? So this is what I want to give the conclusion from the basic linear term. Okay, so that means between input and output there is a linear relationship is there, right? So here we are using the term that linear for the code word, right? So any code, if you want to say it is a linear code, it is very simple. Okay, when we will say that is the linear code, so it is very simple. Whenever you are performing regarding any 2 code words in that according to that particular coding system, okay, when you are having 2 code words, just perform the modulo 2 addition. Can you recall modulo 2 is nothing but which logical operation? Modulo 2 addition is nothing but which logical operation? Modulo 2 addition. So that modulo 2 addition if you are performing, then if you are going to get the resultant code word, then we will say that particular code word is linear code. Otherwise, it is not linear code. Any guess? All of you please mention in the chart. Modulo 2 arithmetic or modulo 2 addition is nothing but which logical operation? All of you think and tell me. Modulo 2 addition is nothing but which logical operation? Okay, I will mention the answer shortly. Meanwhile, I am expecting from your side, what is the answer? Okay, so meanwhile, I will write the 2 cases. You are having, when this is the message input, the corresponding code word is this one. Similarly, when this is the message, the corresponding code word is this one, right? So these 2, meanwhile, I will write down. So in case 1, they have given 0001. Hi Nikhil. So try to guess what is modulo 2 addition. You might have studied in digital. Which logical operator is nothing but modulo 2 addition? Here regarding message you are having 0001. So for that the code word is 4 zeros 111. 4 zeros 111. Similarly, another case you are having 0011 message bits. 0011 message bits. That time the corresponding code word is 1100 110. 1100 110. 1100 110. Now they are asking for 0010. Now they are asking for 0010. Any guess? It is very simple. Modulo 2 operation means what? Modulo 2 division operation, right? So that means here you are going to get, that is nothing but your XOR function. XOR operator, right? So logical OR operator means 1 plus 1 you are going to get 2. Okay. Whereas here, say for example, for easy understanding, I will write here. When you are performing normal addition, say for example, when you are performing normal addition, that time here you will get 0, here you will get 1, here you will get 1. In the last case, you will get 2. 2 is nothing but 1 0. That is the normal addition. Okay. But here we are mentioning modulo 2 addition. Modulo 2 addition means we are considering only some digit but not carry. Okay. So 0, 1, 1 up to here it is same because we can represent with the help of single digit. After that, whatever, after performing addition of these two bits, whatever the sum bit you are getting, that one we have considered, carry bit we have ignored. Okay. So or otherwise here you can observe like you are having 0, this number is nothing but 0, this number is 1, this number is 1, this number is 2. When you perform the modulo operation, modulo division operation, that time you will get the remainders as 0 or 1, right? So this particular truth table belongs to which logic gate? Obviously XOR gate. So here just perform XOR of these two bits, XOR of these two numbers. 0 XOR 0 is 0, yes, it is satisfying. 0 XOR 0 is 0, 0 XOR 1 is 1, 1 XOR 1 is 0, right? So when you have performed the XOR operation among the message bits, yes, we are getting this one, right? So here also the corresponding code words we have to perform XOR operation. So here 0 XOR 1 is 1, 0 XOR 1 1, 0 0, 1 XOR 1 0, 1 XOR 1 0, 1 XOR 0 1. So you are getting 1 1 4 zeros 1, 1 1 4 zeros 1. Which option we are having? Yes, we are having option B. Option B is the correct answer. In this way, whenever any particular code, if you want to say it is a linear code, okay, if you are having two cases, okay, regarding the code words, if you are performing XOR operation, then you are going to get the corresponding code. Okay, so if it is satisfying like that, then only we will say that particular code as linear code. So here they have given, say for example, in this particular question, they have given these two message bits, okay, and when you have performed XOR operation among these two, that time you are going to get this one, right? So that's why they are asking for this particular message bits, what is the corresponding code word. Similarly, if you want, say for example, if they want, they can frame the question by giving these two message bits and these two corresponding code words, they can ask for this one. Similarly, for any two, like that, because when you're having 4 message bits, that time you will be having total 16 combinations, right? Total 16 combinations you will be having. So regarding any two input combinations regarding message bits, they will give, after performing XOR of those two message bits, whatever the resultant message bits you are going to get, for that they can ask the corresponding code word. Okay. So I hope it is clear for everyone regarding this particular question. So now let us move on to the next question. So this question is very lengthy, so I have kept the question in 2 slides. So all of you take the screenshot of this question. And I will show the continuation part. This is the continuation part. So in this question, it is a question regarding probability of error. In order to have same probability of error, what is the value of E? This question seems to be lengthy, but try to understand this question. Once if you are able to understand, this question is also actually logical question. Okay, with the help of diagram, space diagram, space regarding the symbols. Okay, with the help of the diagram, we can easily solve. All of you take the screenshot of the question. So this is the first part of the question, and continuation part I have mentioned here. Yeah, time up. So whatever the answer you are getting, you can mention in the chart. This is the MCQ question. You're having options, and here in this particular question, you're having simple numbers, right? In all options, you're having 0, 1, 2, 3. At least you can guess, right? At least you can guess. Whatever the answer you're feeling, okay, you can mention the chart. So if anything wrong, then you can correct it later after listening the explanation where you done the calculation mistake or where you stuck. Okay, if you are facing any difficulty, you can overcome easily. But at least you can answer now. Whatever the answer you are feeling correct, you can mention the chart. Right. So here in this particular question, just read the question. When you're having lengthy question, try to read line by line and try to understand what the information they have given and note down that one, and from then you can go further. So that in that way, whenever you're having lengthy question, once if you understand what is the given data and what they're expecting, then at least then you can recall the concept which is required for solving that particular question. Okay, then you will get the idea steps in order to solve that particular question, right? So here in this question they have mentioned you are having the single bit, and regarding that single bit they have mentioned equally likely. Equally likely, obviously when you're having single bit, either we can represent that bit either 0 or 1. Here they have mentioned one important keyword, that is equally likely. That means, can you guess what is equally likely with respect to your probability concept? Yes, very good. Equal likely means for getting 0 or for getting 1, it is having equal probability, like 0.5. Okay, right. Is to be sent across an additive white Gaussian noise channel, AWGN, additive white Gaussian noise channel. With regarding additive white Gaussian noise channel, regarding the noise they have mentioned the power spectral density. They have mentioned here N0 by 2. So that means it is like they have considered both the sides. That means it is a double-sided power spectral density. Negative frequency axis, positive frequency axis they have considered. Whenever they mention N0, it is only for the positive frequency, like that. Now, so regarding the binary signal, obviously you are having either 0 or 1. So in this question, they have represented, see whatever the values here you are having 0 and 1, we will represent in terms of electrical signal, right? So since you are having two possible values 0 and 1, so you can represent. In general, you will represent 0 is nothing but 0 volt, 1 is nothing but 5 volt. Similarly, if you want, you can represent 0 is nothing but minus 5 volt, 1 is nothing but plus 5 volt. Like that, any two possible voltage values you can consider according to your wish. In this particular question, they have mentioned 0 they have represented as P of t and 1 they have represented as Q of t. 1 they have represented as Q of t. And it is used for the transmission along with an optimal receiver. With the help of optimal receiver, you are going to get the bit error. Okay. In order to get the error in the bit, you are going to minimize. Okay. Whenever if you want to minimize the bit error rate, that time we will use optimal receiver, right? Obviously, at the transmitter section, whatever the bits you have transmitted, at the receiver you should receive ideally those bits, so that you no need to lose any information, or whatever the information transmitter section side they have transmitted, you should receive ideally, right? So that is our main motto. So that means even in the noise also, in the channel, even the noise is present, but still the effect of noise should be as minimum as possible. So that means in order to minimize the bit error probability, we will use the optimal receiver. Now, they have mentioned phi 1 of t and phi 2 of t are orthonormal signal. Orthonormal signal. Can you guess what is orthonormal? Here you can break this word into two parts. One is ortho, another one is normal. Any guess? Orthonormal. Here ortho indicates what? 90 degrees, right? So orthonormal, this word we will use only when we are considering these two are vectors. So whenever you are having any vector, it will be having magnitude and it will be having phase angle, right? So here phi 1 of t, phi 2 of t, these two are differed by 90 degrees. Now, they have mentioned P of t as phi 1 of t and Q of t as minus phi 1 of t. Okay, that is a case 1. we would obtain certain bit error probability. So they have mentioned it as P suffix B. In general, we will represent bit error probability as P suffix E, but in this question they have mentioned P suffix B. Okay. So when you have considered P of t, Q of t like this, that time the probability of error which you are getting, that is nothing but PV. Now in case 2, what they have mentioned, regarding P of t they have kept as it is. They have kept as it is regarding P of t. Whereas regarding Q of t, have you observed the difference? Here minus phi 1 of t is there. Here root e phi 2 of t is there. Okay. Here in this case they have modified regarding Q of t. Okay. Now see the interesting sentence here. What they have mentioned, for what value of e would we obtain the same bit error probability? So that means with respect to case 1, whatever the bit error probability you are going to get, in order to get the same bit error probability in case 2, what should be the value of e? That is the question. Here in this question they have mentioned P of t, Q of t like this, whereas here in case 2 P of t, Q of t like this. Okay. In order to get same bit error probability, what will be the e value? That is the question. So whatever they have mentioned here, try to draw the diagram. From there you will get the clue. Okay. Right. So first of all, here if you observe 0 we have represented P of t, 1 we have represented Q of t. Okay. Regarding P of t, Q of t, in case 1 you are having like this. Here both the terms you are having in terms of phi 1 of t, right? Phi 1 of t. So here I am considering phi 1 of t like this. Okay. Phi 1 of t like this. So if you are considering phi 2 of t, we will draw the line vertically. Okay. So for the timing that is not required because with respect to this one, you are having phi 1 of t minus phi 1 of t, right? Say for example, here this is the 0 line, the point is 0, say for example. So here you are having minus phi 1 of t. So minus 1 into, sorry, one is you are having minus phi 1 of t, another one is phi 1 of t. Phi 1 of t means on the positive side, right? So here you are having 1 unit. 1 into phi 1 of t is nothing but phi 1 of t. Similarly, another one is minus phi 1 of t. So that is nothing but minus 1 into phi 1 of t. See, it is very simple. Say for example, this is the x-axis. Okay, here you are having x units. Here you are having minus x units. That's all. Okay, so here P of t is nothing but phi 1 of t. So that means this is one symbol, this is one symbol, and this is another symbol. Okay, now let us consider other case. Here you are having phi 1. Here you are having phi 2. So this is case 1. Now I am drawing the figure for case 2. Here we have to consider phi 1 of t and phi 2 of t both. So in the question they have mentioned phi 1 of t, phi 2 of t are orthonormal. That means these two vectors are separated by a angle of 90 degrees. That's all. Okay, here you are having 90 degrees angle. That's all. Here for the timing I have considered like this. Say for example, if you want phi 1 of t, you can consider like this. But from there you can consider 90 degrees like that. Okay. Now, regarding P of t same, phi 1 of t. So that means this symbol we can keep as it is here. This symbol we can keep as it is. 1 into phi 1 of t. Now, other symbol Q of t they have mentioned root e times phi 2 of t. So here phi 2 of t you are having here. So there you are having root e times. Here you are having root e times phi 2 of t. Okay. So with respect to case 1, you are having one symbol here, right? So among these two symbols, obviously when you have observed the distance you are going to get here between these two symbols, only possibility is this one, right? If you want, you can draw other lines also, but among all this is the minimum distance, right? So d min equal to how many units? From 0 to 1 unit, From -1 to 0 also 1 unit. Together you are having 2 units. 2 units. Right. Now in this particular diagram, you are having the first symbol as it is at the same place. But what about second symbol? Here you are having. Earlier you are having here, but now they have placed here. Right. So when you have placed the symbol here, now in this case, the minimum distance between these two symbols will be, when you draw the line like this, you are going to get the minimum distance. When you draw the line between these two symbols, okay, then you are going to get the minimum distance. Minimum distance. Okay. So here, this is the 0 point. Okay. So here you are having 1 unit. Here you are having root E units. Okay. Now can you calculate d min in case 2 by using Pythagoras theorem? I hope all of you are familiar, right? Yeah. So mention what is your d min in case 2. In case 2, what is the d min you are going to get? All of you give it a try. It is very simple. Yeah. So in case 2 you can get, in case 2 you will get d min equal to square root of here you can consider this side square plus this side square, right? So this side square is 1 unit plus this side you are having root E units whole square, right? So 1 square is nothing but 1 root E whole square. Square and root both will get cancelled. You will get 1. You will get 1. Okay. So square and root both will get cancelled. So simply you are getting E. Okay. So with respect to case 1, you are having d min as 2. With respect to case 2, you are having d min as root 1 plus C. Root 1 plus C. Now in the question they have mentioned that in order to have the same probability of error, that means now just by observing these two diagrams, are you getting the clue? Are you getting the clue? In order to have the same probability of error, what we have to make equate? Yes, very good. Obviously, the d min should be same. That's all. See, in this case, you have kept the symbol here. Okay. Because of that, you got 2 units. Okay. You can place this symbol anywhere in this coordinate system, right? Anywhere you can place, but in such a way that if you are able to get the same d min, that means same 2 units if you are able to get, then obviously the probability of error will be same. Correct? So that means in order to have the same probability of error, we have to make the d min. D min is nothing but the minimum spacing between the 2 symbols. Okay, that should be same in both the cases. Okay. So in case 1, case 2, now we are equating the d min, right? Yes. So in this case, we are equating the d min in both the cases, right? So in case 1, we got 2. In case 1, we got d min as 2 units. Whereas in case 2, we got root 1 plus C. Root 1 plus C. Okay. So just perform squaring on both sides. So you'll get 2 square is nothing but 4. Here square and root both will get cancelled. You'll get 1 plus C. From here you will get E equal to 3. That's all. It is a very simple question, but it is a logical question, right? An interesting question. Okay. So once if you are able to draw the diagram, okay, with respect to symbols, how much space it was deferred. Okay. So if you are able to draw, after that, if you are able to catch this one line, in order to have the same bit error probability, this is the main keyword in this entire question. Okay. So with the help of that, we are equating the minimum spacing distance between the 2 symbols. Okay. Once if you are equating both, from there you are going to get E value as 3. Right. So for this question, if you look at the choices, you are having 3 in the option D. So that means option D is the correct answer. Option D is the correct answer. Okay, so I hope it is clear for everyone. So in this particular session, we have discussed the selected questions which are asked in the GATE 2019, right? So whoever missed the earlier sessions, so kindly watch those lectures also. Earlier I have covered the last recent 4 years GATE questions which are asked in the recent 4 years. I have discussed the selected questions. So those lectures will be available in the playlist, right? So in our YouTube channel, IMS GATE Academy YouTube channel. So just check the playlist regarding communication system subject, the previous questions. Okay. So you can find the playlist. So there you can watch all the lectures in sequence. So this is the 5th session, right? So with this, we have covered the recent 5 years or latest 5 years selected GATE questions which are asked in the EC branch and IN branch. Okay. So from this series of lectures, I hope all of you will get a lot of confidence regarding communication system subject. Generally, students will feel that the communication system subject is a very vast subject with respect to syllabus, okay, and even with respect to solving wise also it is a tough or difficult, okay. But if you are able to follow these lectures, definitely it will give lot of confidence for all of you. You will get good number of concepts and good number of models how to solve the communication system questions, right? Ultimately, the confidence play a vital role in your GATE exam. Okay, if you want to attempt any question correctly, if you are confident, no matter the level of the question it is, no matter the difficulty level of the question it is, okay. Once if you are having good knowledge, if you are having the basics of any subject, and if you are confident, that itself will be sufficient to solve any particular question. It's a matter of time. In how much time you are able to solve that, it will the play a game. That's all. Once if you are confident, and once if you are able to understand the basics, and from the given question, if you are trying to understand what the given data, what they are asking to calculate, and once if you are able to apply whatever the formulas you are having. See, especially in the communication system subject, EMT, analog circuit subject, etc., you are having lot of formulas, equations you will be having. But if you want to by heart the equations, then after few days you may forget. But if you want to remember any formula for long run, if you are putting the practice, okay, while practicing the questions, if you are able to recall the formula, you are substituting the given data, in that way you will get the familiarity about the formulas. This is the way of remembering the formulas for long run, right? So all of you kindly watch this series of lectures, whoever missed earlier, okay, and try to share this playlist with all of your friends, so that whoever preparing for the coming GATE exam, they also will get benefited from by watching this series of lectures, right? So whoever not yet subscribed our channel, so kindly subscribe our IMS GATE Academy YouTube channel and click on the bell icon in order to get the instant notifications, right? So that you won't miss even single video, right? So all of you whoever attending these sessions in live, try to attend based on your possibility, and due to any reason if you are missing any session in the live, try to watch the recorded lecture that will be available in the playlist. And after watching every lecture, whatever you have learned something new in that particular lecture, try to mention in the comment section, and whatever you have liked the most in that particular session, and that one also you can mention. And don't forget to like the button and share that video with your friends, okay. So try to like as many videos as possible and mention your comments, so that your likes, your shares, your comments will means a lot for us, okay. Thank you everyone. We'll meet you all in the upcoming session, okay. Thank you.